In a relational database, we can have one-to-one, one-to-many, or many-to-many relationships between tables. We looked at a single products table in our last episode, but now we want to look at the orders and the order items table that has a one-to-many relationship between them, meaning that the order items table has an order ID foreign key that references the ID of the order. And this will help us identify which order the item is part of. And this is roughly how a JSON structure of our request body is going to look like. We are going to have an array of items where each item represents how many of a product there is in this order. And there are also other fields like the payment method, text price, shipping price, and the total price of this order. So let's imagine what we have to do to create an order. We'll first have to insert into the orders table and also insert each of the item into the order items table. And we are often going to have more than one item, but imagine what would happen if a single insert query fails. By the time this query fails, we would have already inserted an order and any item that comes before that item. So to make this more reliable and atomic, meaning we want these operations to be a single process, we want to group all these queries together. So this is what is known as a database transaction, and we can group multiple queries into a single transaction. And we can begin a transaction and roll back the transaction if any of the queries fail, and only commit if all of them succeed without any error. And now that we have an understanding of what a database transaction is, let's move on to the implementation. I'm going to start from where we left off in our last episode, and I first want to define my order and the order item struct. I already have these prepared to save us some time, but basically we have a slice of order items in our order struct, and this order item struct we have defined down here that has the quantity, the product ID, as well as the order ID. And we actually don't need these JSON tags that we added last time because we're going to have separate structs to marshal our request body into. So I'm going to get rid of these real quick. And now that we have defined our structs, we can go into our store MySQL file. And down here, I'm going to add a method for our CreateOrder that accepts a context as well as a pointer to the order struct. And this also returns a pointer to the order as well as an error if there is. And as we saw in our slides earlier, we have to insert into the orders table and also into the order items table. And we actually want to group them in a transaction. So here we want to start a transaction and commit the transaction if there's no error and roll back if there is an error. And to handle these database transactions more easily, I'm going to add this helper method called execTX. So here we have MySQL store and call this execTX that accepts a context and a callback function that accepts a sqlx transaction as its argument and return an error. So Copilot actually gives us a suggestion, and this really should do our job. Here we call begin TXX to begin our database transaction, run our callback function, and if there's an error in our function, we're going to roll back our database transaction. And if not, we can commit our transaction, meaning we commit all the queries in that transaction. So what we can do now is come back to CreateOrder, and we can call ms.execTX here and define our callback function in here. So this is where we are going to insert into orders and the order items. And this execTX is going to return us an error. And we can say if there's an error, we can return nil and an error saying something like error creating our order. And if there's no error, I can return that order struct. So first we can define a private method to create our order. And this method is going to take in a context as well as a transaction struct. And this is actually going to be sqlx.tx as well as our pointer to the order struct. And this will return a pointer to the order and an error. This gives us some suggestion, but I'm going to ignore that for now and call named_context on our transaction database and run this insert query to insert payment method, text price, shipping price, and total price. And remember, we pass in our order struct as our last argument here, and this returns a SQL result as well as an error. And if there is an error, we are going to return an error saying error inserting order. And with this SQL result, we can call last insert ID to extract the ID. And if there is an error trying to do this, we can say error getting last insert ID. And we're going to manually assign the ID into our order ID, and lastly return the order if there's no error. We're also going to do something similar to create our order item. So again, this takes in a context, a transaction database, as well as an order item struct. And we're just going to return an error if there is. And we can call tx named_context, pass in a context, and the insert query. Again, this is going to return a SQL result as well as an error. And if there is an error, we can say return nil, or actually just an error saying error inserting order item. And again, we can get the last insert ID. And if there is an error, we are just going to return the error getting the last insert ID. And we're going to manually assign the ID in the order item and return nil if there's no error. I think there is an extra bracket here, so I'm going to delete that. And you might wonder how we have this order ID in our order item struct, but we are actually going to assign that from up here. So here we are first going to call CreateOrder, pass in the context, the transaction, as well as the order struct, and this will return an order and an error. And if there is an error, we're going to return saying error creating an order. And if you remember, our order struct has a slice of items. So I'm going to iterate over the items in the order. And this is where we are going to insert into the order item. But before we do that, we have to assign the order ID from this order that we just created up here. So that's actually how the order item has the order ID that it is part of. And this is later passed into the order items table through the order ID field. So back here, we can really just call CreateOrder item, pass in our context, transaction, and the order item. And this will return an error if there is one. And if there is an error, we can just say error creating the order item. And if there's no error in our transaction, we have to return nil here. So that was a little bit of work. We can now move on to our GetOrder method. So here I'll add a method called GetOrder. And I'll just take the Copilot suggestion because it looks good. But please keep in mind that we are getting the order based on the ID for now. But later on, when we associate the orders with a user, we are actually going to get order based on the user ID. But since we don't have any user for the time being, we're just going to leave it as is. So all we're doing here is call getContext, run this query to select the order, and this will assign the order into our order struct here. And then call db.selectContext to select all from the order items where the order ID equals to the ID of the order. And we have a slice of items where the values from the select query will be assigned into. And then we can assign these items into our order items. And right below this GetOrder, I'm going to add a method called ListOrders. And I actually spelled this wrong. This will be store This will return a slice of order structs and an error. And I'm going to take the Copilot suggestion because it mostly looks good. Again, we're calling select context and assigning the values from the select query into our slice of orders. And then we're going to iterate over these orders and run this select query where order ID equals to the ID of each of these order. And then we can manually assign these items into each of the orders item slice. And now that we're done with the list orders, we could actually move on to the update order, but we're going to skip the update order for now because we're going to add a method to update order status later on when we work on the notification system. So we can now move on to our DeleteOrder method. So inside our DeleteOrder, we're going to delete from the order items and the orders table in a database transaction. We'll have to make sure that we delete from the order items table first because we won't be able to delete from the orders table if there's an item from the order items table still referencing the ID of an order. And please keep in mind that we need database transaction only when we're modifying our table. So we need a database transaction when we are creating our order, updating, or deleting. And if we're just reading from the database for the GetOrder and the ListOrders, we wouldn't need the queries to be in a database transaction. And just like we did in our last episode, we want to write our unit tests as we go. But because it may take some time to write those tests one by one, and it might make this video really long, I already have those tests prepared, so I'm just going to copy and paste and go over the points that I feel is necessary. So down here, I'm just going to paste a test for creating the order. Let's run this test just to make sure it's working. So that is working as expected. And in this test, I have a slice of order items as well as a struct of order. I'm defining my test cases here, a success test case, a test case for failure to create the order, or a failure to create an order item. And down here, I'm going to iterate each of the test cases and pass in our testDB into our store and call our tc.test, which is the test defined here. If this test structure doesn't make too much sense, I suggest you go watch the previous episode where I go over these in greater detail. So for the success case, we are calling expect begin. That expects a begin call of our database transaction. And here we have an expect exec call to insert into the orders table. That will return us a SQL result with the last insert ID equals 1 and number of rows affected equals 1. So we'll have one insert query into the orders table and two insert queries into the order items table. And for our success case, we expect our database transaction to be committed. And once we have defined our expect calls, we can call CreateOrder on our store. So this store is passed down from this argument here, which is defined down here. The store that's instantiated with this new MySQL store. And we should expect there's no error and the ID of the created order to be equal to 1. And for failure to create the order, we make expect exec return an error saying error creating the order. And because there's an error, we expect there to be a rollback. So when we create an order, we are going to have an error. And same for creating the order item. The insert query into the orders is going to return a SQL result, but the insert query into the order items is going to give us an error saying the error creating the order item. Again, we can expect a database transaction rollback. So when we call CreateOrder on our store, we expect there to be an error. Moving on to the test for the GetOrder, I'm going to paste what I have already prepared. So this test is very similar. We have a slice of order items as well as an order struct. And here we define our order row where we call sqlmock.newRows to define our columns and add a row with the fields that are passed in from this order struct here. And we have an expect query for the orders query that will return the rows that we defined up here. We also have SQL mock rows for the order items, where we add a row for the order items, the first element, and the order items second element, which is from the slice up here. So we define our order item rows, and we expect this query to return these order item rows. Then we can call GetOrder on our store that returns my order. Then we can call require.equal to make sure the ID equals 1. And then we can also iterate over the items to make sure that each field of our order item is equal to what we defined up there. And we have a case for failure to get the order. We expect this query to return an error, and we can just call store.getOrder, and pretty much the same for failure to get order items. So the query to select from the orders will return the rows, but the query to select from the order items is going to return an error. So when we call GetOrder, this is going to return an error. And this is just an optional test case, but we can also test for failure to commit our transaction. So when we call commit, this will actually return an error saying error committing transaction. So we also expect an error here. Lastly, I'm going to paste the test cases for listing the orders and deleting the orders. So I have a test case for deleting the order and listing the orders. The test to list order is really similar to test to get order. So we have the order rows, the order item rows, and the only thing different would be checking for the length of our order, and same for failure to query the orders and querying the order items. And the test for delete order is the most straightforward. We just have an expect call for the delete queries inside a database transaction, and we can just add test cases for failure to delete the order item or the failure to delete the order. Just remember that the delete from the order items table is going to come before the delete call on the orders table. And let's run go tests on all our tests just to make sure everything is working as expected. I'm going to open up my terminal, cd into ecom API store, and I can do go test -v -cover. And as you can see, we have a 96% coverage of all our tests. And this is probably because I didn't add all the test cases for errors coming from calls like last insert ID. But all we have on this video should give you a full picture on how to query multiple tables with relationships. And that is all I have for this video. Thank you all for watching.